And welcome to Climate Chat. I am your host, Dan Miller, with my co-host, Leon Simons. And today we're going to be talking about how climate scientists account for different kinds of emissions, including greenhouse gas emissions and aerosol emissions, and how they don't actually treat both the same, and how that can impact predictions of climate impacts, such as warming, for example. And uh, you may have noticed, if you follow us on Twitter, that Leon has been posting about that recently and putting up some charts showing, what's going on here? This looks kind of strange. So Leon, welcome. And what do you have to tell us about this interesting subject?
Hi, Dan. So I came across this graph where they showed CO2 emissions from Canada, and especially highlighting the emissions from forest fires. So the forest fires emissions from Canada in 2023, they were off the charts, and many know that there were a lot of forest fires in Canada in that year, and that it was really an enormous spike in these called boreal forests, so the forests that are at the higher latitudes, which are these vast forests which cover North America and the north of Eurasia, and so there were a lot of these forest fires. And as you know, I've been looking a lot mainly at aerosols, and then I noticed that in the aerosol forcing, so the effect of aerosols on the climate, there was in the IPCC based method, it was quite low in 2023, and that was because of this increase in emissions from aerosols. And then I noticed that, so I saw these CO2 emissions from Canada, and I thought, okay, I'll check the source, but then it took me a while to find it. And it was the Canadian greenhouse gas emissions report, and that. And I already knew that the accounting of greenhouse gas emissions and aerosols, which are the two main drivers of climate change, it isn't really. It's also one thing is that it's quite complex, and most or few people understand how this accounting works. But also that it's of course this is what countries agreed upon, and of course that's favorable to large exporters also, or every country agrees upon it, and large exporters of fossil fuels have strong say in this as well. So then I wasn't, in a way, it was very noticeable when I saw the data that it didn't really include these enormous emissions from these Canadian forest fires. And I'll explain it with some slides.
Okay.
I can share my screen.
All right.
Well, not the best way to do this, but can I do that here? Share screen. Yes.
There we go. Looks good.
Yeah, so this is really nice, right? You see the greenhouse emissions per person from this new report from from Canada, from a research organization which assesses the greenhouse gas emissions from Canada. And you see, of course, there's a decrease, there's a blip here in 2020 where, of course, during COVID, the CO2 emission, the greenhouse gas emissions, so the total greenhouse gas emissions per person decreased, and they stayed low. And also, if you look at the greenhouse gas emissions per the amount of money that goes around in the economy of Canada, you see that also the greenhouse gas emissions are decreasing. So that's really nice to see. But as I just mentioned, it seems that there's something missing here. And there's this enormous increase here. You can see this spike, and that's from the forest fires. this is caused by forest fires in Canada. And you see that this is a million tons of CO2 equivalent. And as you see that in 2023, that there's 1,100 million tons. So that's 1.1 billion tons of CO2 equivalents emitted by these forest fires. But as I just showed you, that doesn't end up in the accounting of how much Canada emits, how much greenhouse gases are emitted over Canada, because that's not part of their accounting. And I also made this where you can see where if people saw the document by Al Gore, where he points out the CO2 increase and then also the expected temperature increase, right? And he needs a scissors lift to do that. And
right.
yeah, we also need a scissors. It's really off the charts, and that's total net emissions minus removals from managed forest land. So that's all of Canada's forest. So this is not showing up. It's really, I had to go I had to look at this report, and I couldn't find it. And then eventually at page 208, I was able to find this graph, which someone shared on Twitter. So it's really what I call the fine print.
So just to be super clear, so this chart is showing the actual emissions of CO2 from those forest fires off the charts, as you're saying, but you're also saying that this is not included when Canada calculates its CO2 emissions to the world and the CO2 per person and that kind of thing. And why don't they count that?
So it's in a way, it's like assumed that it's like forest fires are happening naturally, and then if a forest burns down, and it will regrow, and of course then it will take up the CO2. So that's and of course in a way that makes sense. But the atmosphere doesn't really care about that, right? So we also see a record increase in the past years of how much CO2, the amount of CO2 accumulation. So how much the increase of CO2 in the atmosphere is also record high, while the amount of fossil fuel emissions of greenhouse gases, especially and CO2, are also still record high, but they are more slowly leveling off. Of course, they're not going down yet, but they are leveling off. But then if you then have an enormous increase in the increase in the amount of CO2 in the atmosphere, that's a very worrying sign, because that indicates that the carbon sinks. So the nature, the especially plants, of course, they need CO2 to grow, and then they use it to store solar energy in their biomass. So that's how plants. That's called photosynthesis, and that's how plants store CO2. But if that is decreasing or net decreasing, that means that even if the plants are growing faster because there's more CO2, if forest fires also increase, of course, then what we call the land sink, the amount of the sink, so the storage by plants on land, that is decreasing as well. And that what happened in 2023, but also in 2024, we saw a very strong increase in how much the concentration of CO2 increased. So and you can say, okay, that makes sense. This is natural, or it's what we call a feedback, because it's getting warmer. There are more forest fires. But then the next, but that doesn't happen to aerosols. Get to that. I just want to point out one more thing here, because that was the accountant, in a way that's not accounted for, right? So if you have an accountant, of course, they look at your balance sheet at the end of the year, and you say, okay, this is how much tax you have to pay, and that's the same what happens here. This is how the accountants look at how much CO2 is emitted, and they write it up and they publish a report. And what this production? You see, there's many lines here, but here's the purple line here. That's Canada. Of course, you can see the enormous increase in oil production in the United States because they increased oil production through new technology, especially fracking and horizontal drilling. So Saudi Arabia has kept increasing. You see the dip in the oil prices, but Canada has also been increasing a lot. It's over 3. The unit here is hours, so there's 1 trillion watt-hours of energy stored in this oil, and you see that's over 3,000 terawatt-hours of energy in this oil. But then if you look at how
Canada.
much, here's again is Canada dollar here, but here you see again Canada, and that's much lower. The oil consumption is much lower than what they produce. And then oil export is also, that's not accounted for in the Canadian emissions because they export the oil. So then, and then it will be shown on the balance sheet of the United States, because here is, of course, now they're almost breaking even with 10,000 terawatt hours of oil. They almost produce as much as they use. But China is importing much more than they use. So then this is the emissions associated with the burning of this fuel are then transferred to the balance sheet of the country which imports these fuels. So that's how this works, how this accounting works. But of course, in a way, you could say Canada is also responsible for these emissions because they are the ones producing it and selling it. It's like a drug dealer. If they sell it, if a drug dealer sells drugs, of course, it's entirely the same, but they are responsible for the effects of the selling their product. If you're a drug dealer and your accountant sees that you sold a lot of drugs, they won't say doesn't matter because you didn't use those drugs. So yeah, it's
apropos. That's a very good analogy in many ways, I guess. Yeah. So just to go back to so there's two. Let's just focus on the CO2 emissions from forest fires and the aerosol emissions from forest fires. Let's just look at those two things in Canada. How are they treated? Those two things. How are they treated differently?
Yeah. So there's let me show you this, and then I'll get to your question.
Okay.
This is what it's called the time evolution of effective radiator forcing. It's a mouthful, but the forcings are what forces the climate to change. I've talked about that in the past, right? And this shows all the different impacts of the different all these dips here. Those are natural. Those are those are aerosols. Where it's volcano. So you see if these green lines go down, the thin black line also goes down, and that means that the aerosols, so the air pollution that especially enters and that's mainly sulfur, that reflects sunlight back to space, and that causes temporarily for the Earth to cool down. But there's also aerosols. These are called tropospheric aerosols, and these are emitted mainly by humans, because it's when we burn stuff, there's also a lot of air pollution being emitted, especially sulfur, because the fossil fuels have a high sulfur fuel content. That means that when it's burned, the sulfur goes into the air and it forms these small particles that reflect sunlight and form clouds, and these clouds also reflect sunlight. We've talked about it in detail in the past. So that's the gray line, where you can see that over time, more and more aerosols were being emitted, more and more air pollution was being added to the atmosphere by industries, and then it flattened out all the clean air regulations, and then now it starts to decrease. So you see now it's the amount of aerosols start to decrease, and so the aerosol forcing becomes less negative. So the warming effect from greenhouse gases is starting to win more than the cooling effect from aerosols. So you might think, right, that makes sense. Human greenhouse gas emissions, human aerosols, those even each other out in the start, and now the aerosols are decreasing. But here you can see that it's quite low here, and I've pointed out this 20. The aerosol forcing is quite negative. It's the best estimate of the IPCC methodology. And why is that? That's because of these Canadian forest fires in 2023. Because those are just added to a simple model, and they are averaged out over the entire planet and assume that they are just the same as the effect of shipping emissions. So that it doesn't matter whether you have forest fires over Canada or whether you have all these 50, 60,000 ships over the oceans emitting the sulfur. It's just particles in the atmosphere, and they cause a certain effect, and it doesn't matter where they are emitted. That's how the IPCC method treats this. And then what they also assume in their estimate, so in their accounting, is that these aerosols, these cooling aerosols from these forest fires, are anthropogenic. So in a way, they assume
by arson. I understand. Right?
So they assume when it's greenhouse gases emitted, when it's CO2 being emitted from these forest fires, they assume it's natural, it's just happening, and they will grow back. But if it's aerosols, in a way, they assume that all these forests are started by humans, by arson, and that it's all human sources in a way, and then those emissions are, as I just explained, added to the cooling effect of these aerosols. And I think that's really wrong. And I'm not alone in this. I can show you, because there's this new, now these Forster et al., they publish every year an update of these IPCC methods. And two reviewers, they ask these questions. So let me just read it, because it's really important. So this is quoted from the paper, from their 2024 paper describing 2023. And it says, women caused burning feedback due to the extreme heat or natural occurring. We choose to include them in our tracking, as historical biomass burning emissions inventories have previously been consistently treated as forcing. For example, in CMIP6. And CMIP6 is a model, is like all these models that the IPCC uses. So the IPCC models assume that these forest fires are forcing. Though this assumption may need to be revisited in the future. I agree with that last part. And then the reviewer asks, do you mean consistently treated as an anthropogenic forcing? If so, and as an aside, that's quite an assumption. So just to highlight, I'm not the only one surprised here. And there was another reviewer of this paper who was also quite surprised about this and also noted this. And even the paper itself, as I just highlighted, mentioned it. And I appreciate it, but I appreciate it's not really up to the authors to deal with that issue here. Yeah, I don't know. I don't agree with that last part. I think if you want to update the IPCC methods, I think this is a really crucial aspect to update, because otherwise you're missing crucial information. And then they say, yes, indeed. Yes, it is considered an anthropogenic forcing. Because it's hard to attribute. Yeah, I agree. Of course, it's hard to attribute, but that doesn't mean that you can. The CO2 emissions are also hard to attribute, but that doesn't mean you have to include them, or at least not do one for the one thing and do the other for the other, right? Because if you say the aerosols are anthropogenic, I would think you should also say that greenhouse gases are anthropogenic. Otherwise, you are really not representing well the impact humans have on the climate. And let me stop sharing here.
Okay. And by the way, let's send a shout out to Ryan, who's watching the show live, who posted that original I guess this graph, I think it was, that you saw and you responded to. And,
yes, exactly.
So
Thank you, Ryan.
Thanks, Ryan.
Yeah, thank you for sharing the fine print. Let me. Okay, how do I stop sharing? We're here.
Oh, here, hold on.
Can you do that?
It's funny, but yeah, hold on a second. I'll just do there we go. Up, and we can go to that.
Yep.
Might make it a little better. There we go. So it's just kind of funny that you can treat the emissions, aerosol emissions from forest fires are anthropogenic, but CO2 emissions from forest fires are not. And it's kind of that simple, isn't it? I mean,
yes, that's what the IPCC method is doing, and Ryan was surprised by this, and the reviewers were surprised by this, I've been surprised about this for quite a while. Also, because I read a study where they showed that the decrease in aerosols could cause an increase in forest fires, even more than the warming from greenhouse gases, because those aerosols, they reflect sunlight and they cause more clouds, and there's other things to include there. So the anthropogenic aerosols, so including emissions from coal plants and emissions from shipping, they were reducing, according to one study, the forest fires from northern latitudes, from north, especially also from Canada. So then, if you then treat the emissions from these forest fires, which are caused by a decrease in aerosols, as if they are anthropogenic, so human caused, and cause cooling, so then you really misrepresent the science.
Mm-hmm.
And then I don't think it's a suitable excuse to then say, because it's hard to estimate, because more things are hard to estimate. But yeah, you cannot just like put these, because this really impacts, of course, especially the rate of climate change. If you get this wrong, you get the speed of climate change wrong, and all the impacts that come from that. So I think this is really an important thing to correct.
Right. Isn't it also that countries that are trying to meet their Paris Accord, obligations of reducing emissions, they're going to show that they're doing better than they really are. I mean, yeah, they're going to show, hey, we've reduced all this, even though this other aspect is growing tremendously. Oh yeah, but we don't count that we consider that to be natural. So we're, from a global warming point of view, it doesn't really matter whether you account for it as natural or anthropogenic. It's still going to warm the planet the same amount.
Are never. Sorry.
Yeah, go ahead.
Yeah, and of course aerosols are also not counted, and that of course then it's very tricky, and you can understand that then if you would say, if you reduce aerosols, if you reduce air pollution, you cause global warming. So you have to also show that in the impact of CO2 equivalents relative to GDP or relative to right. I can understand that they don't include stuff like that, but in a way, if you really want to understand how fast the climate is changing and what contributes to that, in a way you should include that in the accounting, right? If you say again, if you send your expenses or your income to your account, or you send your income to the accountant, but you don't include your expenses, for example, or you don't include very big retainer, your accountant in a way is responsible, and they will say, okay, this doesn't work, right? But then if the whole climate system, we just make these enormous, from my perspective, these enormous accounting errors. Because it's really like, if an accountant makes these kind of mistakes, which like completely change the bottom line of your results. So at the end of the year, like they would be fired, or they would end up in jail, right? Because it's malpractice. And I think in a way this is the same. This is also in a way malpractice. And I don't use it lightly because it's really the whole climate system that's at stake here, and we better get this right.
Right. Yeah. And it's, well, I guess it's not too surprising that they try to almost rig it, I guess is the word you might use, to make it look like we're making more progress on our own emissions than we really are. And by the way, you did mention, we have talked about it previously, the difference between a forcing and a feedback. But I think it's worth just like quickly summarizing it again, because a forcing is something that we do directly to affect the climate, like emit CO2 or emit sulfur particles that reflect the sun and cause clouds. Now, the cloud thing is interesting, whether that's a feedback or not. But
Yeah, so
and this gets to the hard. Well, I just want to get about water vapor, because very often you'll hear a climate denier saying, "Ha ha ha! Water vapor is a much more important greenhouse gas than CO2." And it is water vapor is a very powerful greenhouse gas, but it's not a climate forcing, because the world isn't getting warmer because we're emitting more water into the atmosphere. The amount of water in the atmosphere is determined by a lot of things, including the heat, how hot
mainly
the atmosphere. Yeah, the temperature, and that temperature is controlled over the long run by CO2. So water vapor is a feedback to the CO2 and makes the CO2 warming much stronger in a way, because it's not only the CO2 warming, but it's CO2 warming plus water vapor. I want to say that because that's the heart of the discussion we're having today here is what's a forcing, what is something that humans are doing to change the climate, versus what's a natural feedback. And those feedbacks will get you just as much as the forcing. So in fact, they could get out of hand soon.
Indeed. So that's indeed crucial. That the greenhouse and the CO2, of course, also is a forcing. So when we burn fossil fuels, that CO2, the additional CO2 in the atmosphere, forces the climate to change. And then the feedback is as the amount of CO2 increases, the oceans take up CO2. So that's a feedback in a way, right? The dissolve the ocean, the CO2 in the atmosphere dissolving in the oceans, but also the plants growing faster because they have more CO2 to produce biomass. So the photosynthesis is more efficient. They use more of the sunlight that hits them to store energy in these carbon compounds, but it also produces more fuel. So if you say CO2 is plant fuel, as some of these climate deniers like to say, that's like, of course that's plant fuel. That's like the first chemistry lesson you have. You learn that photosynthesis is C6, so 6 carbon atoms and what is it? Six oxygen atoms. So C6H12 O6. So that's how these sugars. That's a composition of sugars. That's really one of the first things you learn in chemistry class and in biology as well, and at least here in the Netherlands. So that's not rocket science, and you don't win a Nobel Prize by saying that CO2 is plant food. But that also means that it is plant food. But it also means that it produces more fuel to burn when the forest starts burning, when it's drier and when it gets warmer, and when these bark beetles don't die because the winters don't get as strong, and they kill the trees, and then the dead trees, they don't take water out of the ground anymore, so they burn more easily, and then when the aerosols disappear, there's more sunshine shining on these dead trees, and they dry out faster, and then you get these really enormous especially, of course, in these taiga forests, enormous areas of fuel which start to burn, and that's what we're now starting to see. So I wouldn't really disagree that it's a feedback. I think you can call it a feedback from our emissions, but also fertilizers, nitrogen fertilizers, right? Feedback from our emissions. But that you also have to do that with aerosols. You cannot just say,
right,
have your cake and eat it too.
Right. So you're saying the forest burning because it's getting warmer and drier is a feedback to our past greenhouse gas emissions, really, and not just CO2, but methane as well, and others, nitrous oxide. But what we really care about, because the thing you experience is the forcings plus the feedbacks. You never just experience the forcings only. In fact, I guess I don't know. I don't know if I've seen like what the temperature would be if there were zero feedbacks. It would probably be not very much, actually.
Well,
maybe
zero feedbacks.
Yeah, it would be like what, half a degree warming maybe by now or something like that.
That doesn't work. That's like infinity or something. You always need feedback, because if there's warming, you would need, of course, a response from the system. And so
well, yeah. I'm just saying, but the CO2 only effect. The CO2 only effect is.
So, no, for example, if you would say the only feedback is the Planck feedback, which is the main feedback, which is negative, which means it counteracts the warming effect from CO2. Then indeed that's 3.22 watts per square meter for every degree Celsius of warming, which means that there's then there would be very little warming from a given amount of CO2 increase. But that's of course not happening. There's also indeed the water vapor feedback, as you already talked about, where the atmosphere can hold 7 or 8% more water for every degree Celsius of temperature increase. And then the amount of water increases, and that also absorbs sunlight. Also absorbs infrared radiation from the Earth, keeping the planet warmer than it would be without this water vapor feedback. And then there's also the cloud feedback, which you discussed already quite some detail, or we discussed already quite some detail here. Where
that's a big one.
If the ocean heat or if the land heats up, also the clouds rise higher, but also the atmosphere again can hold more water vapor. So these clouds evaporate faster, and then there's less clouds and less white surface or area to reflect sunlight back to space, and that increases warming further. So that's what we call a positive feedback, which means that it increases the warming from a given forcing. Whether that's
a reinforcing feedback is better terminology. Reinforcing feedback. But the thing we experience is the forcings plus the feedback. That's the world we live in, and we don't live in a forcings only world as you're just describing. So that's this whole thing too. And if you did that, if you only were talking about forcing plus feedback, then it wouldn't matter which category you put it in. I mean, it is important because the forcings are what we kind of control directly, and the feedbacks are sort of out of our control, as we're seeing. It's not like, we're going to try to suppress forest fires using new technology like satellite, trying to find the beginning of the fire as quickly as possible and have very fast response times to put them out. But for the most part, it's the warmer, drier world is going to have more forest fires and therefore more CO2 emissions and aerosol emissions. So
and then again, I have to point it out one more time that these aerosols, because you say in a way sometimes it does not, if you just care about how much CO2 increase, the amount of CO2 increase, of course it matters what causes that, but the effect of the CO2 increase doesn't really, of course, it doesn't depend on whether it's a feedback or whether it's a result from burning fossil fuels, because this CO2 distributes within a year or so quite evenly across the planet. with all the strong winds and blowing and distributing the air around the planet. And then because it's a gas and it stays very long in the atmosphere, that's what we call homogeneous, so evenly distributed forcing. So what that is concerned, for CO2, it's less relevant whether it's a forcing or a feedback. But with aerosols, it's very different, especially because these aerosols are not distributed evenly around the planet, but the shipping aerosols, as we discussed in detail, they are, of course, emitted over the oceans because ships sail over the oceans. So that's where the effect is. So you cannot, if there's a feedback of Canadian forest burning, that you cannot pretend like that's a forcing which is equal to sulfur emissions.
Okay. Hey, but by the way, you have a clip of Kevin Anderson talking about something similar. Do you want to introduce that?
Yeah. So as we were talking about the accounting of forcings and feedbacks and CO2 emissions and aerosols, of course, that's what we now discussed is more about the past. So what happened in the past and what happened in 2033 or what's happening now. But you talked about a year ago. You talked with Kevin Anderson, and there you discussed the net zero, and Kevin called that how that is treated by companies or by governments, and also in reporting. He called that a scam, an accountancy scam, and he can explain it much better than I do. So please show the video. Can you do that? Should I?
Well, I can. Let's see.
Why is net zero problematic, and what should we?
Let me start again.
Why is net zero problematic, and what should we be striving for instead?
I think it's turned out to be a scam in how it's been used. You might argue it had some scientific legitimacy originally. But if you go back to the previous set of IPCC reports, assessment report 5, net zero wasn't mentioned in there at all, and not in the way we use it today. In the UK, the Committee on Climate Change, in its 5th budget report, it didn't mention it once. In its 6th budget report, it's there several thousand times. And so it's almost every page. And so let's be clear, net zero is not a phrase that we've been using for a long time. It's a phrase that has come up almost overnight. And the media use it, the academics use it, the funding agency uses it. So everyone there, every company uses it. Everyone talks about net zero. And overnight, we've adopted that language as if it's always been there. It hasn't. So at a purely scientific level, all we're talking about with net zero is balancing inputs and outputs into the atmosphere of greenhouse gases. But that's not what we're doing when we're talking about it in our normal day-to-day speech. What we're talking about there are all sorts of scams and ruses that we're using to avoid making the difficult decisions today. And we can think about this. It's an accountancy scam. It allows us to do all sorts of things. It allows us to exchange between different greenhouse gases. So we can start to substitute, and this is substitution is a real accountant's dream, if you like, a bean counter's dream. You can say, I'll swap a few molecules of CO2 for a molecule of methane. Well, these are very different in terms of how long they last in the atmosphere, their chemistry in the atmosphere, the levels of certainty involved with them. You then say, well, we'll think about the carbon dioxide from a car journey today versus animal husbandry projects in 2030 that might affect methane emissions. Well, now you're passing it over time between a guaranteed emission from a car or a plane today and possible changes from methane emissions in pigs in 2030. And then you think, well, maybe we'll plant some trees and we'll talk about carbon dioxide absorption in 2035 versus some industry emitting today. So we then substitute between greenhouse gases that have very different chemistries, very different times in the atmosphere, very different levels of certainty, and then we pass it across time as well. And so this allows us to do all sorts of scams in our spreadsheets to make it look like we're doing quite well, whether that's a company, an institution, even an individual, and certainly for countries. And then another scam on top of that, I think sort of like the cherry on top of the scam cake, are these things called negative emission technologies that sound that they exist, that, let's just use negative emissions. We say it now, and it doesn't sound odd to us anymore because we've used that language for so long, for the last 3, 4, 5, 6 years, if not a little bit longer now, that almost like, well, of course we can just use negative emissions, but there are no negative emission technologies out there at scale. There are a few pilot schemes and they just capture a few thousand tons here and a few thousand tons there, whilst we're putting about 40 billion tons of carbon dioxide into the atmosphere every year. And so they're another scam in the spreadsheet. So rather than have to do something early in the spreadsheet in the year 2024, 2025, 2026, you can say, oh no, we'll apply some negative emissions in 2035 or 2040. That means we don't have to make those difficult changes today. So at every level, you can scam this net zero. And this is why you find BP, Shell, Exxon, Saudi Aramco, they've all got net zero targets. The UK, Canada, the US, the Saudis, they've all got net zero targets. We all have net zero targets, yet we're all seeking more fossil fuels.
Right.
So we're all in net zero. Everyone's bought into net zero. Surprisingly, the emissions keep going up and the temperature keeps going up. So somewhere in it, the physics has said we can see through that scam. But the rest of us, we love it because it deludes us and it allows us to avoid those deeply political, difficult questions we do not want to have to ask. Or worse, we don't want to have to answer them.
So you had a lot of things.
Yeah. So let's switch here. There we go. Yeah, covered it quite well there. Yeah, we're kind of doing everything we can to make it sound like we're doing something to fight climate change when we're really essentially doing hardly anything. I mean, there are positive things. Absolutely, the growth in renewables are great, and they would be even better if we actually use them to offset fossil fuel emissions as opposed to just growing total energy. So we have the capability to do things, but I guess the short-term political and economic impacts, people are just not interested in paying attention to this stuff or something. If you don't have anything else to add, we could go bring Stacy on and go to questions, or do you want to make a few more comments here?
I just want to make it the comments by Kevin Anderson. I want to make them a bit practical, just to show what is done. So, for example, I went with a group of young energy professionals to the oil refinery of Shell, and after that, and of course, I asked a lot of questions about the desulfurization of the oil they import from Kazakhstan instead of Russia. After Russia stopped importing from Russia, right? So, and that was quite interesting. But what we also did there was visit a project where they are transporting the CO2 because to empty gas fields or exploited gas fields in the North Sea. And so what we had there, what they showed there is in a way just the pipelines where they were transporting this, where they would or are going to transport this CO2 from different peak sources in the port of Rotterdam, and the oil refinery that we visited from Shell, they have also have a smokestack where CO2 comes out of, but that's 100% CO2. If you burn fossil fuels, of course, there's a lot of nitrogen because the air is 80% nitrogen. So in the exhaust gases, there's a lot of other stuff, especially a lot of nitrogen, than just CO2. But these oil refineries, they also with their processing of the fuels, they also produce 100% CO2, and they feed that into the pipeline together with two other parties. They export it to these gas. They will export it to this gas field, and the annual mitigation of CO2 of these three big emitters will be 2.5 million tons. But the oil that Shell alone cells, if it's burned, it will emit 40 million tons.
Mhm.
That's in a way that's related to Canada exporting all their oil and not accounting for the CO2 emissions. It's called Scope 3. So
Right.
that's very often that's ignored. So the effect of the CO2 emissions from the product you sell when it's burned. And again, 2.5 million tons, that's one of the world leading carbon capture and storage programs in the world.
Mhm.
And now compare that to the 1.1 billion tons of CO2 equivalent emissions from these forest fires in just 1 year from Canada.
Mhm.
So that's really, and then indeed, if you talk about net zero and you talk about all these negative emissions, it's like no one I know who works in this area believes that it will ever be can be used as a compensation of emitting
Mhm.
or burning fossil fuels. It will be a very long stretch of helping to reduce the amount of CO2 that's already in the atmosphere in the long run.
Mhm.
But these emissions, these orders of magnitudes are really crucial to understand. And then if you understand it, you will know that it's really indeed a very big scam.
Yeah, actually, many people will be surprised that many fossil fuel companies have net zero plans. And what those net zero plans are to reduce the CO2 emissions from their production facilities down to zero or offset them somehow. But as you just pointed out, what they're not counting is the fact that they're shipping out a product that, when used as directed, emits orders of magnitude more CO2, and that doesn't count for them. That no, we're net zero. What are you talking about? Oh, the other guy who's using our product, he's not net zero. You should go.
Oh, I didn't know they would be burning it. I didn't know they would be burning
Who
it.
knew that would happen? We ship it to gas stations and people put it in their cars. Who knew they would drive? I mean, But anyway, um, it is kind of breathtaking the extent. I mean, and obviously in the United States today, we're even worse than ignoring the problem. We're denying the problem at the official levels of government, which is pretty crazy as well. And as Neil deGrasse Tyson said, the nice thing about science is that it's true whether you believe it or not. And that's true of climate change and global warming. You don't have to believe it. Doesn't matter. It's going to happen anyway because we're emitting 40 billion tons of greenhouse gases into the atmosphere every year.
Yeah, you can hope or you can wish that it's not true, but physics doesn't care and nature doesn't
Yeah,
care.
let's bring Stacy, and I don't see Eli. You were there before, Eli, but if you're out there, come on back.
Hi, Stacy.
Welcome, Stacy. Oh, wait, you're muted or something. I think.
Yep. Sorry,
Oh, there
I
you
was
go.
muted. Yeah,
Okay.
and I will say hi to Dan and other Dan, as everyone has been noting that
Oh, Leon.
Leon's name is Dan Miller, and so everybody's been, it's like Dan Squared, Dan Jr., they've been all
Oh.
commenting on that. So
Can you change that right away? I don't even know. You do it when you log on. You got to look for that, Leon. Yeah, when I logged on, Leon, it said my name was Leon, so I changed it. So that's what happened there.
It's interesting.
A little fluke we got to work on.
Oh, maybe it's whatever. I can give you my thoughts. But it's funny, when the show was announced, I have been really busy this week and I haven't seen all your tweets about this. I assumed it was about the carbon offsets and how some of them are, like, oh yeah, really, that's gonna offset it,
No, this is different.
Or they're just, it's fraudulent. I wasn't thinking about that our actual tally is off. But I did want to ask, so I guess what is this? The accountants that you want to fire are the Task Force on National Greenhouse Gas Inventories with the IPCC. Is that who we're talking about?
I think this
in
is
a way,
the
it's the entire
Canadian
IPCC process.
The whole process.
IPCC. Yeah.
Because so I know, and it's funny that Eli's not here because we definitely are the
Oh, yeah, now
chorus
he
in the
is.
background on the things that they do say, we don't know how to count this. And we're both agog at like, how can you not account for forest fires, soils and soil carbon, glacier melt and ice sheet dynamics, permafrost thawing, ocean acidification, and extreme weather events. Like these things are not, it's one of those like our compute isn't fast enough, our math isn't good enough or something to capture all the directions that these could go or are going. And they seem like very large glaring oversights. I mean, would you agree? Is that?
Yeah, so it's in a way it's in the Excel sheet, but it's just like hidden in the tab, which like you need a password for to access it, right? So you need to follow Ryan on Twitter and interact with him once in a while to be able to even know about it. So that's I think that's part of the problem where you can always say it is accounted for. Look, like if look at page 208, it is we do account for it, but it's just not us who is admitting it, right? And then so I think that for the CO2 emissions, I can be still a bit. I'm still a bit understanding, but it's really also the combination with counting one and not counting the other, and the impacts that has on the understanding of the effects that are now taking place.
Okay. And Tom.
We have Eli there. Eli, do you want to join in there on this or make a comment now or a question? I see you on, but you might be muted if you're trying to talk, but okay. Anyway, Stacy, go on. Or maybe Eli will join a little later.
Tom was firing off a few questions. So he asked, do the numbers from Canada take into account the minor countering of aerosols from forest fires? Where do these aerosols have the greatest effect? In Europe? Or sorry, and I guess he's saying also and in Europe. How about there?
Yeah, so do numbers. No. I think that's really the greenhouse gases and the CO2 equivalents. And I would have to look. Again, it's not very clear, and I would have to go to the supplements of the supplements, I think, and maybe send some emails to get really to the bottom of what is included in the CO2 equivalents of the graph I showed you with the CO2. These what was it, the 1.1 billion tons. Maybe there's some black carbon in there, some methane, but of course it's mainly CO2. But then, I don't think the aerosols are included there. But the question in Europe is really crucial, and I'll show you why. Now, let me share my screen again. Does it work here? No. I am sharing it. I have to put it. Can you show it, Dan?
What am I showing?
Oh, here it is.
Okay.
No, my screen.
Okay.
I'm doing it now. I was already sharing, but stopped showing. This is European summer warming, and if you look at certain climate models, and it's called the Cordex, where they show summer warming of Europe, and the purple line is the average of these models, and this is the 5 to 95, all these model runs, and then this the ECMWF era. See, it's even above the range, so that's summer warming. And why is that? Because these models, they don't include reduction in aerosols over Europe. And then that's how Europe and some parts even more degree of additional warming happens than the model in summer. Sorry, so the summer warming is more than 1 degree higher than the models show if you don't take these aerosols into account. And the KNMI also uses this Cordex, and it still uses old data sets. And then you really underestimate warming of Europe. And then, as I highlighted before, I think in 2022 we had 60,000 heat deaths in Europe. In 2023, 50,000 heat deaths estimated in Europe. And we really need this to be taken very seriously, because these spikes, these extreme heat in summer, when the warming is more than the model's estimate, is really underestimated. And then the heat plans are not in place to take these extremes into account, because the models don't show this yet. And that's not just for the KNMI, but it's also important for energy companies or grid companies that want to know how much water is available in the reservoirs for cooling or for the power plants, whether it's coal or nuclear or whatever, and for hydropower production, and for what you call donkerflauten. So how the weather changes when there's no sun or no wind, right? You really need to take all these changes, real world changes, into effect if you want and respond to the rapid changes that are already happening and that are upon us. So yeah, I think that's an important aspect. And again, another graph I showed this week, where I show the Earth's energy imbalance based on NASA data, right? Where they use these satellites to look at how much energy comes in from the sun, how much is reflected, and how much heat is radiated back to space. And then this shows that there's about a tripling in how much heat accumulates on the planet, and the unit here is million. So that's Hiroshima bombs per average over 4 years, and that's now it reached a record of 11.4 Hiroshima bombs per second for 4 years running. So that's really mind-boggling. So yeah, so there's much more heat accumulating globally, and especially over the northern hemisphere mid-latitudes at the moment, because that's where we reduced this air pollution, which was of course reflecting a lot of sunlight back to space. And that will impact the climate where most of us live and grow our food.
Okay. I see that Tom asked the other question. Should I go to that one there? And this is, are forest fires connected to the decline in natural sequestration of CO2 worldwide? It's a 2-for-1 less forest for sequestration, more CO2 because of the fires. So, as you know, the world, as you were pointing out, we emit a lot of CO2, but a lot of it gets absorbed by oceans, soils, and plants. But as these forests burn, these sinks are becoming sources, and very dangerous. Also in the Amazon, it's another area where that's happening. But do you have further comments on that, Leon?
Yeah, so indeed, the Amazon is an important region as well, which has now in the past decade turned from a sink of CO2, so a forest that stores more CO2 than is emitted, to a net source of CO2. So emitting more CO2 than it's stored, and that's because of all the land clearing and because of all the drying and the increase in forest fires in the Amazon. And I remember a study which showed that even if you decrease forests, you could also decrease wind. So you could decrease how much wind is coming from, and that brings rain from the oceans because of the evaporation. Because in a way, these rainforests, they produce their own rain because the water lands on the trees and then it evaporates, or the trees, they grow and they, in a way, they breathe, they exhale also a lot of water vapor, also to keep themselves cool. So then they produce their own rain, and the pressure difference that also produces winds, and that creates also a draft from the oceans, bringing, of course, wet moisture, rain, also air from the ocean, and bringing also rain and also nutrients from the Sahara all the way to the Amazon. So by destroying the Amazon rainforest, that it's also called a tipping point that impacts not just the regional climate, not just the carbon sink, but also turns it into a source and has a lot of global implications through all these feedbacks. So that's really, it's a bit complex, but if you have to take these things into account to understand if something is changing, if the Amazon is disappearing from land clearing and from climate change, that could have disastrous effects around the world.
Okay. And Stacey, you want to do Nadia's?
Yeah, so I think greeting, Nadia is in Berlin. Hi, Nadia. And she says, aren't feedback emissions, for example, the polar methane release, wetland CO2, a thing that should cut into those budgets? That's another lie, no?
Yeah, well,
Hallucin. Wait, let me think. Feedback emissions from.
she's saying like we have carbon budgets, yet when we get emissions from the Arctic melting, from permafrost or whatever, that eats into the budgets, doesn't it? And the answer is yes, it does, unless those emissions are already accounted for when the budgets are constructed. So then the question is the IPCC taking into account all these feedbacks that we're getting now and will get? And whenever you hear the phrase, this is happening more than scientists expected, that's sort of saying that, no, it's not really included in the budget. So I think a lot of these are not included, although some of them are, right? Leon, do you know how much of these feedbacks are properly included in the budget?
When you look at the fine print, again, of the carbon budgets, because that's, of course, in a way it's related to what we discussed already, but it's also in a bit of a difference, then like the end of the discussion, right? So what does this all mean for the carbon budgets? How much CO2 can we still emit before reaching 1.5 or 2 degrees of global warming? And if you look at the numbers, it also says like 100 million tons or 100 billion tons of CO2, or like 500 billion tons of CO2 for 2 degrees. But then the fine print says this is dependent on how much methane and other greenhouse gases and aerosols change. So in reality, of course, methane is still going up a lot. So the methane concentrations are going up a lot, and that's also, as we discussed recently, could also be a result of the decreasing sulfur emissions. And also because the decreasing sulfur emissions are, that also has an effect on aerosols, which cause more warming. So if you take this into account, if we are honest, there's no carbon budget left.
Right. Well, certainly for 1.5, there's no. We're at 1.5.
No, for 2 degrees.
For 2 degrees, also.
There's no carbon budget left for 2 degrees, right? Even in an instant human extinction scenario, where it's very, very unlikely that the planet will not warm by 2 degrees. Of course, also because of all these feedbacks, already these forests are on fire. Already the Canadian forest, the Amazon forests are turning into sources of CO2. So if you look at that, and if you take into account this stronger aerosol forcing than estimated by these IPCC models, and taking into account that these forest fires are not aerosols, which you can just nicely homogeneously put in a model, then there's no carbon budget left whatsoever.
One thing,
It's a negative budget.
one thing that I don't know, why there is such denial from these capitalist societies. I wonder how much of it is that they may even get it, but the way that you make more money is you make more stuff. And if every once in a while you come through and erase a bunch of stuff and have to rebuild, I mean, I could even see on the left, like construction job creation or something. You know, we are ants on a pile, all moving stuff around and doing our little things. And we make more people and we have to do more stuff. And that this is just a way of, hey, if everything were calm and normal and didn't change and lovely and consistent, there wouldn't be as much change for them to capitalize on. It's a thought.
Hey, let's see if Eli can come in. He's been having trouble with his mic, but Eli, can you say something? See if you're there.
Yeah, can you hear me now?
Oh, there we go. Now it works. Okay,
so
great. Welcome.
This is on Chromebook. Okay, so kind of stepping back, this is, both the continuation of the minimization and almost denial, of accounting for what we're up against, and also maybe, trying to shift around who is responsible for doing what. But I think we need to ask the question, is, all of the net zero accounting more like a mirage where if we even did get there, it would turn out that it's too little too late. And maybe we have to start thinking about better strategies, both in terms of how we fight to do what we can about climate, and also figure out the task ahead of us. Open-ended question.
Okay.
I just want to. We didn't talk about this yet, but I think if we are discussing the IPCC, I think it's important to highlight that there's a lot of scientists spending a lot of time and free time on these IPCC reports, and there's a lot of great science there. But that also means that it's quite a toxic relationship, right? Because these scientists are not even being paid, and then you have then you have the politicians and these policymakers deciding in the end what is done, or how this accounting happens, or how this or what will be communicated broadly, right? If one country says let's not talk about sulfur, it will not be in the summary for policymakers.
Mm-hmm.
So then I think that's really a really toxic relationship between all these scientists spending a lot of time and doing a lot of effort and providing their decades of experience to the process, and then these politicians just wiping their ass with it in a way. And I think that's important to note.
Okay.
I also wanted to make one, what came up in the comments, and we get this a lot in the comments, and Dan takes a lot of heat for this. And I think that, I know that Eli, Dan, and I are on the same page because, I've been with Dan for 4 years now doing this. And Leon's newer to the bunch. I think he is on the same page as well. And that's about SRM. None of us want to have to employ SRM. Hear us. None of us want to have to do it. It is only because we believe it will be the only option. We are not proponents of it. In fact, Eli is working on a project that wouldn't be a chemical, injecting sulfur into the atmosphere, but rather a mechanical one that could be potentially, it would be turned on and off. These are things, it's like none of us want to have to do it. It's just we're looking at what is happening and nothing is changing. I mean, I ride a bike everywhere. I barely fly. I mean, it's been years. Like I trains, transit, I'm all for this. Everything I do is about transportation and changing the way people and goods move. This is not something that we want. And so when you think, don't label us cheerleaders for it. We're not. We're just trying to mention that this might be our only option because people aren't changing the way
Well,
they
but I wouldn't
live.
say only option. I would say one. It's one of the tools that we're going to need to deploy. It's the only tool that responds quickly.
Right.
All the others, if you cut your emissions, let's say we did cut our emissions to zero in 2050 or 2060. Even if we did that, we wouldn't notice it for many decades. I mean, things wouldn't be as bad as they would otherwise get, but they're going to continue to get worse. I would say also
And
people think. Well, let me just
and
finish on this.
sorry.
Okay, go ahead.
Well, but just wanted to mention, and there are calculations that argue that even if we had stopped emitting in 2020, we would still be on course for the heating that exists to melt the polar ice caps, or excuse me, the Arctic, right?
Yeah.
Just that, which is why I said earlier, net zero could turn out to be a mirage, right? We don't want to do anything like solar radiation management, but we're probably going to break the climate system and all of the ecology that fits into it if we don't do something different than what the IPCC
we don't want to do that either.
has been doing.
Yeah, there are consequences to emitting 2.6 trillion tons of CO2 cumulatively. So, and even if we start to slow that down, those 2.6 trillion tons were still emitted. But I want to say that on this, people think that I'm optimistic, that I'm techno-optimistic about things to fix the climate. And I really have to point out is that I'm really far more pessimistic than most people are. The ones who are optimistic are those who think, A, that we're going to lower our emissions, that think that's a thing that's going to happen starting next month. We're going to really get on this and start. No, we're not doing that. Number two, that even if we did do that, that would somehow be an acceptable outcome because I think, well, among climate scientists, I think it's pretty much, well, some might disagree. Some are really super optimistic. But among practical climate scientists, there's no way we're not going over 2 degrees, even if we decide, which we haven't decided, but if we do decide to lower our emissions drastically, really drastically, make social change and things like that. We're not doing that. But if we did, we're still going over 2 degrees. And 2 degrees is like catastrophic. It's not the end of all humans. But just look at what's happening now and multiply that a few times, and that's pretty bad. So I'm actually I'm very optimistic about what we could do, but I'm not pessimistic about what we will do. And therefore, I think we need to focus on what I call Plan B things. Now, Plan A is reducing emission. We have to do that. None of the Plan B things work very well if you don't also do the Plan A. But we haven't done Plan A, and we're not doing Plan A yet, but we will someday because, by the way, nature will make us do Plan A eventually if we don't do it ourselves. But the Plan B things, which are removing CO2 from the atmosphere and doing reflecting a little bit of sunlight, by the way, 1 or 2% of sunlight, it's not a lot, will have a positive effect and buy us some time to do Plan A. So I'm just saying, I'm actually rather, people think I'm optimistic, but it's really, I'm talking about these things because I'm quite pessimistic, actually. All right. We had.
Can I respond to that too?
Please.
Yeah. So I think it's quite ridiculous to be straight thing to say that we are like pro sunlight reflection method or geoengineering. It's like saying your chemotherapist, your cancer doctor is pro chemo and really would love to see you put as much chemicals in your body as possible because he just is some Dr. Makela or something. Right? It's really completely ridiculous.
Thinks
And
chemo is for everyone.
I think it's good. Please let me finish. I think it's important to be straight about this because everyone studying aerosols has to or working on this has to deal with this crap where people keep saying, you know, oh, you would love to be like Dr. No and you or whatever they call and intentionally play with the climate system. No, we have a really big problem. My country will be under multiple meters of sea level rise. You know, this is and it's not just my country; it's Bangladesh, and it's all the major cities in the world. And then, and even when we just discuss it scientifically, then it's treated like the worst thing in the world. Just to try to understand how we can make sure that the worst things don't become reality. And I think it's important to point that out once in a while. Thank you.
Yeah, that's what Eli. Eli, are you there?
Yeah. Okay. It took me a second to unmute. Yeah. Just you know, it's not that chemo is for everybody. The more, the better. It's that these changes, many of them will be irreversible once we get past tipping points. And you know, extinction is forever. We are in an accelerating mega extinction event. Climate is not so far the dominant cause. Land use is the dominant cause. Land use also causes climate change, but it will, you know, we are close to the point where climate disruption and the attendant ecological disruption becomes the dominant driver of mega extinction. And again, extinction is forever. We don't want to go down that course if we can avoid it. And there are tools. We have to get out of denial and start responsibly analyzing, developing, and deploying the right tools for the job.
Yeah, but I'm going to comment on some things in the chat about there's 10 degrees of warming in the pipeline. Leon was a co-author of the global warming in the pipeline paper. That's not a that's a scenario. That's something that says if I forget what it was, if we maintain the forcing at a certain level or something like that for a certain amount of time, then this is what happens over a very long time period, by the way. You get to 10 degrees. That was not a prediction of what's going to happen. In fact, it's almost guaranteed not to happen. It's either going to be better than that or it's going to be worse than that. We're not going to maintain the forcing at a constant level for all this time. So we talked about it previously, but Leon, why don't you jump in on that one?
Yeah, to be completely clear, so what this model that's a model estimate where we assume that the greenhouse gas concentration stays at the doubling of CO2, which or a CO2 equivalent, which is already at the moment. It is already at over 4 watts per square meter. If you add up all these different greenhouse gas forcings, based on how much is there in the atmosphere, already, if you would have just keep it there at like a stable concentration, of course that's purely hypothetical, for thousands of years, you will end up at about 10 degrees Celsius of warming. But for that to happen, all the ice sheets would need to melt, for example. So the entire Antarctic ice sheet would need to melt, and that's 50 to 70 meters of sea level rise. And the Greenland ice sheet would need to melt as well, and all the Arctic sea ice would be long gone. And then, but then you keep the even doesn't matter whether it's from feedbacks or from forcings, you would keep the greenhouse gas concentration at that level, right? So of course, that's not going to happen. That's a purely hypothetical scenario. I think the global warming in the pipeline paper was much more about what will happen in the near term. So accelerated climate change because we have these also emissions in the pipeline, because there's over a billion cars, there are still 100,000 flights a day, because there's all these coal, gas, and all infrastructure in place, which, whether we like it or not, will keep being used for a while, and so they will keep adding greenhouse gas into the atmosphere, because people like to eat rice, because people like to eat meat. They will keep emitting methane in the atmosphere, and because we are rapidly reducing air pollution, also for health and environmental reasons, that will add to the warming, and that will cause a lot of near-term warming in the pipeline. I think that should be the main takeaway for people living at today and in the next decades, that they will have to deal with very rapid regional and global climate change. And what will happen in 2,000 or 3,000 years from now, it's scientifically quite interesting. So it's important to include it in the paper, but I think it's less for many people living today. I think most people don't care about what will happen in a few thousand years.
Yeah, I think we should worry about the next 10 here and get our shit together and start doing what we need to be doing. And again, there's many different aspects of that. The science part we actually know pretty well. The solutions part we actually know pretty well as well. But what we don't know yet about is how to get the public to understand the dangers, how to get the public behind climate action. And those seems to be the key things right now. But we're trying to do our part by helping people know. What was that, Leon? What'd you say?
Not just public, the industries,
politicians, everyone, absolutely. But with that, I think we covered the subject well. Yeah, you do want the accounting. You do want to understand the problem well, and that means doing the accounting properly, and so that could be improved as well. But again, to everyone, it really doesn't matter where you put the thing. Whether it's a feedback or a forcing, it's all going to affect our lives. And so think about what the combination is, and that's what's going to get us. So we got to keep focused on that. Anyway, so thanks everyone, and next week we have Dana Fisher on. It's going to be an interesting discussion about climate action, climate inaction, and things like that, and others coming up. So we really appreciate everyone joining us. And Leon, Stacy, Eli, thank you, and Ryan out there, thank you for that tweet that kind of kicked off this discussion. We appreciate it, and everyone who asked questions. So thanks for.
And don't forget to like and subscribe.
That's right.
We're almost at 4,000 subscribers, and if you want to get a highlight when we go live, you have to. I think you have to hit the bell button, and you'll get a notification when we go live.
That's right. We don't do a good enough job of like every other YouTube video, like starts off with, before they say anything, make sure you hit that subscribe button. And it does help, but we're talking about climate communication and reaching people. And part of it is more people that are informed, the better. If this channel had greater reach, that would help a lot in terms of spreading the word of the action needed. So do your part, click like, subscribe, hit the bell, tell your friends, and all of that. And we appreciate that.
And the last point I think is important because we got a few questions about that. Is that this video will be online, and you can share the video. You can also share parts of the video, and then people can just watch it back. So it will stay online. It's even if it's live, it will stay online.
Right, and
it's the same link.
We do film these live, but the moment they're over, they're available for everyone as a recording as well. So anyway, thanks for coming to Climate Chat, everyone, and we will see you next time. Thanks, everybody. Bye-bye.
Bye-bye.
Thank you. Bye.